Hey guys, so this is homework 10.11, and what we're going to be talking about is comparing different experiments or even different treatment groups within an experiment. So let's just start reading at the top. So in a classic experiment, two or more treatment groups are randomly created and then subjected to the different treatments. The question then is how to determine if the variability, this is an important word, variability seen between the two groups is due to the treatment or not. So let's look at exercise 1. Suppose 50 people were chosen to try out a new diet pill to help increase weight loss. The people are randomly divided into two groups. One is given the pill while the other is given a placebo. Remember we talked about this. A placebo is a pill designed to look like the real one but has no medicine within it. There are two main ways variability can be introduced to the results. Discuss each. Okay, so there's two different ways variability can come up. One is induced variability and the other is natural variability. So we've talked about this. This is actually like one of the first lessons we did within the statistics unit. So let's just kind of recap what we came up with here. So induced variability. This is variability occurs because some people are getting actual weight loss drugs. And some people are not. So some of the difference is in the amount of weight loss how much weight loss should be expected to come from taking the drug or not. So let me repeat that, sorry. Some of the difference in the amount of weight loss should be expected to come from taking the drug or not taking the drug, okay? So that's the induced variability, that's the induced part of this. So some people will lose weight because of diet pill, and some won't because they aren't taking the diet pill. Okay, so then let's talk about natural variability. So natural variability, like it says there, variability just because people, animals, plants, etc. are naturally different than one another. So even within one of the two treatments, some people will lose more weight and some people will lose less. The variability is simply due to different people's metabolisms and daily habits and have nothing to do with the pill that they received. So this has to do with just like different people's metabolisms, daily habits, and it's basically just because people are different. Okay, the question then is how can we distinguish between the two types of variability? So we want to know like how much is because of induced variability and how much is because of natural variability. That's what we're trying to distinguish between within this lesson. Okay, so let's take a look at a case study. Exercise 2. A seed company is trying to determine the effect of synthetic nutrients versus organic nutrients on the growth rate of corn plants. Okay, so we're comparing synthetic nutrients and organic nutrients on the growth rate of corn. They select 40 seeds, so 40 is our sample size, and randomly distribute the seeds to two groups of 20. So that means that where it says group 1, this has 20 as its sample size, and group 2 also has 20 as its sample size. Okay, the seeds in group 1 are given the organic nutrients, and the seeds in group 2 are given synthetic nutrients. After 3 weeks, each plant's growth is measured in centimeters. So we look and we see group 1, we see group 2. And right now it looks like it's in numerical order. They organize the data in numerical order. So it says enter these two lists into your calculator, state the mean of each, and then create a box plot or a box and whisker plot for each using the grid below. You may want to summarize the information you need under each heading. Okay, so what we're going to do is for group 1, for all of this information, I want to know the mean and I want to know all the box and whisker plot information. So I can do all of that by, if you recall, we go to stat edit. We plug all the information into list 1. I'm only doing this for group 1, so I'm going to do it one at a time. So I only put in the information for list 1 from group 1. Okay, and then I'm going to go back to stat edit, and I'm going to go to 1 variable statistics. And it's going to show me all the info, like the mean, standard deviation, all that stuff. All I care about is they asked me for the mean, so I'm going to jot that down, 15.15. They also asked me to make a box and whisker plot, so I need a few things. I need Q1, which is 12. I need the median of the whole set of data, which is also known as Q2, and that's 15. And I need Q3, that is 18. Okay, so now that I have that information, I'm going to make a box and whisker plot. I'm going to make, for group 1, my box and whisker plot above this number line. Group 2, I'll make the box and whisker plot below. Okay, so I also need actually the min and the max for group 1. So the minimum for group 1 is 6, the maximum is 25. So I'm going to start by putting a point at 6 and a point at 25. So here is 6, here is 25. Okay, then I'm going to put a point at 12 for Q1. I'm going to put a point at 15 for the median, or Q2. I'm going to put a point at 18 for Q3. Okay, and now I'm going to connect these. These are my whiskers. And then here is the box portion of this. Okay. So now I'm going to do the same thing for group 2. So I'm going to jot down all the information for group 2. So again, I'm going to repeat this process down here, but now I'm going to do it all for group 2, and I'm going to erase the information from group 1. So I'm going to go to stat edit. In list 1, clear that list, and now let's put all the information for group 2 into that list. Then we're going to go back to stat edit and 1 var stat. So I'm going to write down my mean, which is 17.45, and then all my box and whisker plot info. Q1 is 15, the median of the whole set of data is 18, Q3 is 20, and my min is 9, and my max is 28. Okay, so now I'm going to make a box and whisker plot for this information. So I am going to start with the min and the max. The min is 9. The max is 28. Okay. Then Q1 is 15. The median of the whole set of data is 18. The Q3 is 20. Okay, and now I connect the whiskers, and then I connect all 3 of these things for the box. Got it. Okay. So let's see. That's all we were asked to do right now, is just to state the mean of each and create a box and whisker plot. Okay, so now let's look at exercise 3, which also relates to this, so we're going to kind of jump back and forth. So exercise 3 says, let's look at the descriptive statistics that we have so far, which are these sample means, and this is for group 1 versus group 2. And we also have the box and whisker plot. Okay, so the sample means from group 1. The sample means for group 1 is 15.15, and for group 2 it's 17.45. So that tells us that group 2 has a much higher sample mean than group 1. Remember, group 2 was the one that had synthetic nutrients, and group 1 was the one that had organic nutrients. Okay, if we also look at the box and whisker plot, that will give us some information. So the box and whisker plot, we're just comparing, like, what are we noticing between group 1 and group 3? This was group 1 on top, this was group 2. I said group 3, sorry, group 1 and group 2. Okay, so group 2, I notice in general, the box and whisker plot is very much like shifted more to the right where the higher numbers are. Its min and max are higher than the min and max for group 1. Its median and all of its quartiles are higher also. So that does indicate to me that this second group that has synthetic nutrients is really growing more than the first group who has organic nutrients. These descriptive statistics also are suggesting that the plants that are given the synthetic fertilizer, not only do they grow more than the organic fertilizer, but also the mean was higher. So we said that. So group 2 has a higher mean. And group 2 grew more. I mean, overall they grew more, right? So like the max for group 2 was 28, while the max for group 1 was just 25. So that shows me that they actually grew more than group 1 did. Okay, what else do we see? The median is higher, we noticed that also. Okay, one thing though is it doesn't give a clear picture because there were definitely plants that grew more with the organic fertilizer than some that grew with the synthetic fertilizer. So here's what we mean by that. So like let's just pick a number like this number right here. Okay, this whatever plant that received the organic fertilizer grew to 15. What is this in centimeters? But there was a plant that received the synthetic that only grew to 9 centimeters. So there are some plants in group 1 that are growing higher than the plants in group 2. So it's not like every single plant that received the synthetic nutrients is just totally like surpassing group 1. So we have to keep that in mind. That's actually really important. So I'm going to write that down. There were plants that grew more with the organic fertilizer versus the synthetic. That's important. So it's not a guarantee that a plant's going to grow more with synthetic versus organic. It's definitely not for sure 100%, not a guarantee. Okay, so what we're going to move on to now is what we're going to talk about is a simulation and how a simulation can help us determine if variability is if it's based on the induced variability or just like natural variability. So there are sophisticated techniques to determine what portion of the variability in two data sets is natural and what portion is induced. What we're going to do is, well, we're not going to actually run a simulation, but we're going to look at a simulation which was run. And it's going to give us a much more confident sense of knowing whether it's from induced or from natural variability. Okay. So the program that was used to create this simulation is taking the two groups of data and it's going to randomly scramble them up into two new groups. So it's going to take the two sets of data that we're comparing and it's going to mix them up and it's going to create two new groups. And it's going to do that over and over and over again. And it's going to calculate the difference in the means of the two groups. The reason we're mixing them up is so that we have a sense of, we can then look at which group they were part of. It's kind of to compare it. I think it'll make more sense when we actually do the example. So exercise 4. If the mean of sample group 1, so that's where it says sample mean 1, represents the mean of group 1, and sample mean 2 represents the mean of group 2, then do the following. First, find the observed difference in the sample means. Okay, all that means is we're literally just subtracting the difference in the means. So 17.45 was for group 2, and 15.15 was for group 1. So that's a mean difference of 2.30 centimeters. So that means on average, group 2 grew 2.3 centimeters more than group 1. I'm going to write that down. On average, group 2 plants grew 2.3 centimeters more than group 1. Okay, part B. This simulation was done that produced 100 simulations on a frequency histogram on the axis below for the sample mean differences. So all differences in sample means. Point out on the histogram where the observed difference falls. That's what we just calculated. It's the observed difference or the mean difference. Okay. So where does 2.3 fall? Well, 2.3 here is like 2.5, right? So 2.3 is in here. Okay. So we figured that out. Now, obviously, this is a simulation. So, like, if I did a simulation, and then if another teacher did a simulation, or somebody else did a simulation, we could have totally different data, right? Think about when we did like the flipping the coin, or when we did the simulation on the board with the M&Ms in the jar. We got like all different data each time, right? So this is an example of a simulation. Okay. So the next question says, look at the data list containing the sample mean differences. Given that there are 100 differences, what percent of the differences were at or above the observed difference? Okay, what percent of the differences, these all below, these are all when they refer to the differences, these are the mean differences. What percent were at or above the observed difference? Okay, well, I only see two, this one and this one, that are at or above the 2.3, because I don't know exactly, like, this one is not exactly 2.3, right? It goes a little below and a little higher. So only two of them are at or above the observed difference. So of the 100 simulations, only two are greater than 2.3 centimeters. So if I want to know what percentage that is, because it did ask me for the percent, so 2%, 2 out of 100 would be 20%. So only 20% of the mean differences were higher than the observed difference. So you might be thinking, what does this all mean? Okay, so let's read the last question and let's look at that. Okay, we're looking at the last question now. How confident are you about the observed difference in sample means being due to induced variability and not natural variability? Okay, so what that number 2.3 means for like the observed mean difference is it's telling us like how different the means are from group 1 and group 2, right? So it's telling us that they're like 2.3 centimeters is the difference in the means. So what the simulation did is it created like all of these other differences of means between the two groups. And what we noticed is that there were only two things that had a difference in means that were bigger than 2.3. Only two simulations had a difference in means that were bigger than 2.3. So that means that the means are still like mostly below 2.3, that mean difference. So what that actually tells us is that it does give us a lot of confidence that the observed difference in the sample means is mostly attributed to the treatments induced and not natural variability. So it gives us confidence, thinking how we could word this, confidence that the observed difference, so that number 2.3 in the sample mean is mostly from the induced treatment and not just natural variability. If it had been mostly due to natural variability, then we would have expected to see many more of the simulations to produce differences in sample means that are at or above 2.3. So if we saw like a lot of data at or above 2.3 over here, if we saw like a lot of the data from the simulations over there, that would have told us that it actually would have been more due to natural variability rather than the observed mean difference, rather than the induced variability. Okay, guys, we're going to continue to talk about this tomorrow. So what I encourage you to do is, if you have a specific question that you are really confused on, I would star that question. Okay, or if you can write your own question, like something that will help you to clarify what we did, then I would encourage you to also write your own question. Okay, guys, see you tomorrow.